Hello everyone, October 25th. All right, let's do this binary tree. With factors, given an array of unique integers where each integer is strictly greater than 1, okay? We make a binary tree using these integers. And each number may be used for any number of times. Each non-leaf node's value should be equal to the product of the values of its children. Return the number of binary trees we can make. The answer may be too large, so we're gonna mod it. Okay, array of unique integers where each integer I is strictly greater than 1. We make a binary tree using these integers, and each number may be used. Each non-leaf node's value should be equal to the product of the values of its children. Okay, so we start with fallen 2, right? So it has, oh yeah, and 2 by itself, 4 by itself, that's it. 2, 4, 5, 10. Well, the value is unique, so we need to know which one can serve as a parent, right? So we have 2, 4, 5, 10. How do we find that? This is an interesting question. I mean, we can use, yeah, how do we even find that? Array length is 1000. We have to go O(n) squared first to find out all the connections, right? So we have connections in this case. How do I even express this connection? Or we can say, you know, anyone can be a root, right? So we can say if I root at 2 is 1. If I root at 4, we have 1 by itself. And then we can check to see if anything divides by 2. So we check 2 divides, right? So we can have 4 by itself, right? Or 4 can have, because I say it's divisible, right? It's divisible. So 4 has 2. We can make 2 trees. Because 4, if you go from the first one, and the first one we have, which is the same. So depending on how many trees we can make here and how many trees we can make here, right? So and we say have many unique trees. So it's 1 times 1, that's 2. 5, we have 1, nothing. 10, we have 1, 10 by itself, or 10, we can go 2, because I divide by 2 of 5, so we have 2 and 5, each one is 1, so that's times 2, because we can swap, right? Because it's all unique unless these are the same. If the root is not the same, then we can always swap. So that's 1. So that's 2. So plus 2. So that'd be 3. Right, so I have a 1 plus 2 plus 1 plus 3. That gives you 7. So what I think, okay, what I think is we sort array from small to large, and the smallest one, definitely, it's only going to be 1. And each time we go to the next one, we check, right, how many we can divide. Right, if we divide, if it's in it, cool, right? Okay, so something like, something like this. Let's see if it works. All right, so we're gonna say, how do we sort? I forgot again. Forgot again. Array.sort. Yeah, I think it's array.sort. Okay, so it's arrays.sort. Okay. Set integer array set equals new hash set. How do we do that? Initialize hash set. I never remember this. Ah, screw it. I remember. I just go for it. It's okay. It's just a. I can even do it in one line, right? Int a of array. You can say array set dot add. Done. Right? One line. You can consider that as one line. Okay. Don't consider one line. All right. So we get that. Now we're gonna say int dp. Ooh, got it. Okay, mod first. Mod is gonna be 1, 2, 3, 4, 5, 6, 7, 8, 9. All right, that's mod. And dp. All right. What's next? The next is dp0 is equal to 1. Okay. Now what we're gonna do is for int I equal to 1, I smaller than array.length I plus plus. So for each one, okay, then we're gonna go arrays.fill dp with 1. Everybody start with 1. And then we just add additional, right? We add additional. Okay. So we say for this, for int j equal to 0, j smaller than I, j plus plus, cannot reach the current one. So for each one, we need to say if it's, we can say if array I mod array j is equal to 0 divisible and array set dot contains array I divide array j, right? Whoo-wee. Don't like it. Let me redo this. Okay, so we say int. I can do an outside. Int. What you call it? Q. It's quotient. Okay, quotient equal to array I divide array j. Okay, if array set dot contains q, then because it's unique, right? Then if array j is equal to q, right? Then we also need to know. We need to know. Oh my goodness! I don't do the hash set. No. Hash map. Okay, map integer. Array index. That's what we need. Hash map. And then for int I equal to 0, I smaller than array.length I plus plus. We say array index dot set put array I and I. Okay. Then we still use array index dot. Oh, it's not hash. Contains key, right? If it contains key, then we say if they're equal, right? If they're equal, then it's going to be dp. Oh, if they're equal, then it's just going to be dp. Yeah, it's going to be dpj times dpj, right? dpj times dpj. Oh Lord, this might, holy crap. All right, we have to have a long temp. Okay, so temp equal to dpj times dpj. Right? dpj times dpj. Huh, that's such a good question. I wonder Java. Overflow of integer, int overflow during computation before mod. Oh, you get long here. Gotcha. So what we need to do, because these two, we have to make, let's make this long. Let's make this long. Okay, so dp is long. So if dp is long, then I can multiply them. I think it should be fine. But dp is long. I will not store long in dp. It's just, for now. So if that, then we can do that. Mod, right? And what? And so what we're saying is if these two are the same, then the number on the left and number on the right, we multiply together, right? It's the total one, and plus the original one, right? Plus the original one. So it's going to be dp I plus this. Then we're going to mod again, yet again, right? Going to mod yet again. And this is just going to be dpi, right? That's if they're equal, then we do this. If they're not equal, then we'll do something slightly different. Okay, just slightly different. Once you do that, hold a second, that's not right. Yeah, I'm gonna mod again, right? So when we do that, we can do it 2 times, right? And then we'll mod again 2 times, because j and q is not the same, so the root is not the same, so we can swap, right? So that's a contains key. Then we have these 2 results, and I think we can do it this way. If else, right? So blah blah blah, we handle everybody. I mean, we can actually make it simpler. J is smaller than I, and what? And array j times array j, okay, is smaller or equal to array I. If it becomes larger, then it's, goes out. So we can make it don't go all the way down, right? So we have that. And what we compute is what? Using array I, how many we can do. So we do that, right? We do that. So we'll mod, always mod. So we guarantee dp, although it's long, but the value in it is actually short. Okay, the value in it is actually short. And when we're done, right? When we're done, we want to know the total. So we can have a long res. Okay? Long res is 1. And every time when we handled everything, I can just go res equals to res plus dpi, and we're gonna mod, and then we return into res. Three, 6, 12, 24, 48, 36, 7, 49. What are you doing, man? Doing 20. I don't know. 18. Probably get a 9. Just 45. Let's throw some stuff out there, you know. But 40. 72. Right, we got a bunch. Let's try to see how this one goes. Nah, that's not right. That's not right. Okay. This can be our special test case. Let's just add a 3-6. Okay. Holy crap, 3-6 is still right. Okay. Maybe you've got a 24. Got a 12. Okay. Add 2 more, 12 or 24. There we go. Maybe add a 12 is sufficient to make it wrong. Yep. Maybe we just add a 12 or make it wrong. No, maybe I have a 3. All right, let's give this a shot. So of course, we're gonna reorder it. It's gonna be 3, right? 4, 5, 6, 10, 12. Okay, 2, 3, 4, 5, 10, 12. So 2 has a 1, 3 has 1, 4 has 2, 5 has 1, 10 has 3. We know, so 10, we have 3, and 12. How many does 12 have? So 12 we can have 2, 4. No, 2, 6. But 6 is not in there, so we cannot do 2, 6. So we can have 3, 4. Okay, 3, 4. 3 is 1, 4 is 2, so 1 times 2 times 2, so that's 4. So this one should have 5. That's my current method, right? So it's a 1, 2, 3, 4, 5. 5 plus 8, 13. I think that's what I return is 13. It is 13. How come my output is 11? Oh, I think I know. I think I know, my friend. That is not right. That is not that, because we didn't even do Q, right? So it's DPJ. So I is DPJ. So this is not DPJ. This is array index dot get Q. And DP this baby. Yep. Now let's throw this into it. All right, let's do 1. If you try 1. Okay, give it a shot. That's pretty much it. It's the 3rd time we've done this. 3rd time. It's pretty good. This is LeetCode 8:23, right? Use DP, where DPI is the total number of unique binary trees that can be made with array I, first sort array, then use DP, that can be made with array I as the root. For each new array I, we go from the front to find all possible pairs that whose product is array I. Since we know number of unique binary trees created from those pairs, the number of unique binary trees for array I is the product of its subtrees. It's two of the counts of its two subtrees. Note that if the two subtrees have different root, g parent equal to 6, left equals 2, right equals 3, then we need to double the product because the two subtrees can swap position. O(n) squared. dp sort map index contain. Oh, this one go all the way down. Yeah. I did a little bit more so I can, make it a bit shorter, but it's fine. Okay, so that's pretty standard, right? This one's pretty standard. Okay, so we're done with today. Yeah, let's do this. Immunity helper. We've done this one already, so let's just try it again. This dot original equals to object. Okay, so what we need to do is we need a proxy, right, for this one. So we need a get partial copy. So we have the object and p is partial. Wait, isn't the object has to be proxy, right? Oh shoot, I forgot how proxy works. It turns out in my current job, probably don't even need proxy at the current level. May need proxy one day, but not now. Proxy and handler. So, do I create the original as a proxied version? How do I do this? The object has to be a proxied. Mutator. Wait, hold on. Mutator, what is passed to the mutator? Produce, that's a mutator. Right, that's a mutator. So mutator need to pass a... Mutator needs to pass a proxy. Mutator needs to pass a proxy, right, which is a proxy of the original. And in this proxy, we are getting... Hold a second. I don't think this is right. I'm going to say const p prox. Original, right? Shall equal to a new proxy. This dot original, and then we need to have the handler. So the handler need to have a set and a get, right? So we have a set and a set is going to be set. All we want is object. Yeah, let me just copy this. So that is the set, right? I have a set function. Right? Yeah, and then we have a get function. Dude, why you do this to me? Is it too different? Okay, so we have a get function as well. So we have a set, we have a get. And we'll figure out how that one gonna do this. Okay, so we have that, right? And we probably need a partial copy. Okay, partial copy. Right? You set it outside, right? Now, I think it is get partial copy. Yeah, we get partial copy, and we will return a partial copy returns a proxy. I think that's what it is, right? We return a proxy, right? We get a partial copy, and I'll return a proxy. So this one's how I return a new proxy. So obj, and then we have the set and get. Right? So set, we set a prop to a value. What do I do? Do I just, I mean, we're going down to some object, and then we'll set something to a value. So I say p prop equal to value. When we get, right, we'll have the target, and we have the receiver. I don't think I need the receiver. I just need a target. So what do I do here? We're getting a prop, right? We're getting a prop. So I say if O prop is an object, okay? So, okay, const is obj. Obj is not equal to no and type of obj is equal to object. Okay. So we say if is obj O prop, right? If a current is an obj is an object, then we say if P prop is equal to undefined, then P prop shall equal to this, right? Then we'll return get partial. Let's not get partial copy. It is get partial copy. Get partial copy. O prop and P prop. Otherwise, right? Otherwise, it's not. Hold a second. I think maybe I should put this one here, right? And then we set a new, this is first time we hit it, right? If it's not the first time we hit it, it's not the first time we hit it, we shall return let's see if this is equal to undefined. If it is, we return P prop. Otherwise, we return O prop. No, we return O prop. Or we return P prop. So that's get partial copy. Right? Then we commutator. We call get partial copy this the original and partial copy. This is right. Not sure. Send it out. How come I print out two things? Oh, it's two things, yes. So, clone. Smart clone. Smart clone. Look how clone. OMP. ONP. Okay. So when we clone it, okay, original and a copy. Okay. So we'll copy original to the copy. So we say if is obj. If original is not an obj, then we just return original. Right? Wait, hold a second. What are we doing here? We want to return. So this should be the partial copy, right? This should be the partial. Yeah, this is the original, this is the partial. So we say if this will return this. Okay. Otherwise, if they are O is and P is both is, and we just say if, and we just say let result if arrays dot is array, so array dot is array, if O is array, rest shall equal to O, right? And then we shall say for let index in P, right? No off, no in. Yeah, in. Res index shall equal to clone O index. Huh. Right? O index, P index. Else res shall equal to, again, spread it. Isn't this the same? And then we return res. So we'll return produce, return clone original and partial. Yeah, I'll call it partial. Does this make sense? What the hell? I don't understand. Well, for one thing, I think should be key. Well, this one's right. Ugh. Which one is wrong? This one? Yep, what happened? New vowel. We didn't get a new vowel. No. That's interesting. So you're telling me this value is null. I don't know what happened. New vowel is none. I don't know what happened. Array. Okay, and then it's the array. And it is an object. And P wait, hold a second. It's not an object, right? So hold a second. The first one, O, P is this, prop is this. So O prop is an object, P prop is undefined. So P prop equal to this, then we'll get partial copy. So when we return a proxy, right, this one we should return a proxy of that. So return a proxy of that, which is the array, a proxy of the array. Return a new proxy. And then we call get again. So then the next one, What the hell? That's not right. Because the second get didn't get, wasn't called. Oh, should I call target? Oh, what's target? Yep, I think I should call target. It should be target. It doesn't work. Receiver? That doesn't make any sense. It should be target, right? If we want to continue this. Yeah, who is the proxy here? Get. Maybe it's reflect. Maybe it's reflect. Well, maybe it's receiver. I don't remember. Oh, Jesus. I don't remember. Oh, I turned off the... Oh my goodness. Is it reflect or... I don't remember using reflect. Oh. Yeah. This O never gets to... It always stays at this. I don't want to stay. It should be a... Yeah, I think this... I must get it wrong. I don't know how. I thought I just return... You're getting a value, right? But I want to return a proxy. I forgot. I forgot how it is done. Get partial clone. Oh shoot, it's also mutated. Damn. Target prop. It is target. It is target. It is target. Okay, so a couple things, right? A couple things. First of all, what I saw is this. Let's get it down. Oh, because it's no longer. That's why. Okay. Yeah. Okay, this makes sense now. So we do that. Then we'll get. Now I should be able to get O, right? Or I cannot do O. Maybe I cannot do O. If I do O, then we don't have the no, I need a console. That is not right. Right? That's not right. So we're using O is not gonna work. Target. Still not work. Oh, but yeah, no, it's hold a second. This one works. It works. Is this O, right? You call prop. Yeah, because I return a proxy. So when you call this is a proxy. Yeah, this is a proxy. And we'll get it. Yep. So then I think the only thing we need to do is mutated. Right, I think we have. Let's throw some stuff at it, see if this one can handle it. Yep, I cannot. And what timeout? Huh. Yeah, we need a new thing called mutated. False, right? Once we set this, we say mutated equal to true. And then we'll do that. If mutated say res equal to clone it, right? If mutated, we do this, and then we reset it to false, and then we return res. Yep. Yep. A new shot. So it looks simpler than the previous method. I have better understanding of this, which is always good. And we can even make it like this, right? Const res equal to array.isArray. If it's array, otherwise Yeah. And this is OMP. Set and get. All right, let's check. This is a solution, right? I have two trap target. Ah, okay, it's target, so we don't need to use this. I mean, it's fine. If it's not equal to value, get trap. If it's an object, but this is not defined, we do this, and then we'll return. So yeah, that's important. When you get it, when you return is a new proxy, right? A new proxy is we get the next one, a new proxy. Ah, reflect.get. Then why don't you just use target? Or use the original, right? Return a new proxy. You don't have to parse. Yep. All right, that will be it. We go through this one more time. And it was not too bad, but I did struggle. I struggle on this one a little bit. Okay, that will be it. I will see you guys tomorrow.